So I have actually picked out a few problems to do, just 3. And so I'm going to show you how to do all 3 of these problems with categorical logic. All of these have to be shifted a little bit, just like they do on the exam. So this is the argument that we're given. The first thing that you'll see when you're looking at this argument, the first thing that you'll notice is right here, evil, nice, nice right here. Those are all adjectives, those are not nouns. And in order to do a categorical syllogism, you have to have nouns as the subject and the predicate. So the first thing that we have to do is fix those. We have to change those. This so also in the conclusion up here is just a conclusion indicator. We don't have to have that in the final product. Usually what I do, and what most people do, is they draw a line to distinguish the premises from the conclusion. Alright, now how do we know if we have a proper categorical syllogism at this point? Well, is whether or not it's in proper order. A proper categorical syllogism has the major argument first, major premises first, then the minor premise, then the conclusion. You start from the conclusion. So here are our 2 categories that we're dealing with here. Evil people, nice people. The conclusion is always, 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 universally, regardless of what you're dealing with, it is always S and P. This is always S, this is always P. No matter what is here, no matter what is here, it is always S here and P here. And that is true for the entire argument. So evil people, anywhere that it shows up in the argument, is always S, right here. This is S. Nice people, whenever it shows up in the argument, it is always P. And then we have a third term, right here. It's not S and it's not P, the only other thing that it can be is M. Alright, the major premise is the premise that has P in it, the minor premise is the premise that has S in it. Are these in the correct order? No, they're not. How do we know? Because the P one should be on top, which means we have to flip these. So that turns into notice, you can flip these 2, you can flip the premises, you can never flip the conclusion. The conclusion never moves. It always stays exactly where it is, and it never moves around in the argument. It's only the premises that can move. Those are the only items. Okay, so now we have a proper categorical syllogism. It's in the proper order. We have major premise, then minor premise, then conclusion. Okay, well now what do we do? Well, we have already identified our S, P, and M. We've already identified our terms. So what we can do now is to put this into a more easily manageable form. Now that you have the argument built like this, now that you have the argument in this order, it is really, really easy to tell the form of the argument. How? Because form is determined by the M. So the next step is to figure out our mood and figure. So we have both of the M's are right here in a line like this. The mood is determined by these, where you're all know some and some are not. This one you can tell, this is one of the benefits of doing this in multicolored ink. You can see really clearly what the mood and figure is. You've got some are not. So if it's some are not, that is O. And it's the same for all 3 of them. So we have an O, O, O. And then how do you figure out the figure? Well, there's a neat little trick that you can do with your hand. Pick any hand, it doesn't matter. Do like this, okay? Put your hand down on the table without hiding your thumb. And then just bring your 2 fingers together, okay? Now how does this work? Figure 1, figure 2, figure 3, figure 4. It always works like that. Now, how does that help us? Like, what does that actually look like? How does that actually format in an argument? It works like that, and this is where your M's are, and that's how you can tell your moods and figures. And that's why you put those two middle fingers together, close together like that, is to show that they're on those ends. The second figure, the M's are on the far side. The third figure, the M's are on the near side. Those are two really easy ones to get mixed up as far as medium figure goes. Our argument has both the M's on the near side, which means we're looking right here at figure 3. So we have an 0003 argument. Now what do we do? Now let's check for validity using the list. So the list that I gave you, it's a given list, it's in the lecture notes, go find it, make a copy of it. I've got it nice and handy dandy in my textbook here. So we look for an 0003 argument to try to see if it is valid. Now we already know that this is the modern interpretation, so we're only looking at the modern list. And there are no 0003s on this list. You can see it here. No 0003, which tells us this is an invalid argument. But that's only one method. That's one of 3 methods to tell if it's valid. So we're going to move on to the second method. The second method is the Venn diagram. It doesn't matter if you put your M circle on the top or on the bottom. I just flip it over when I'm grading it to tell which one's which, but I always put my M circle on the top. Now, it is very, very, very important that you realize that you never, ever, 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 ever diagram the conclusion. Never. You never do it. When I was young and I was still trying to figure this stuff out and I wasn't very comfortable with Venn diagrams, what I used to do is I'd make an extra little diagram, a 2-circle diagram, that is my conclusion. But the big 3-circle diagram is only for your premises. What do each of these look like? Well, some arguments always have X's, so we're not going to shade anything. If we did have shading, we'd have to do the shading first, because when you're shading, you're saying that a section doesn't exist. So you always want to shade before you do X's. So the first premise that we're going to do, it doesn't matter, you can pick either one, because they're the same. They're both O arguments, so it really doesn't matter which one you want to do. I'm just going to go in order. Some M are not P. Now, if you're still uncomfortable with Venn diagrams, a good way to figure this out is to figure out what it actually means to say some M are not P. Think about what the connotation is behind that. Some M are not P. Well, what you're saying is there are some things that are not the other thing. So look at the P circle. There are M's that are not part of the P circle. Now, a good thing to do if you're still more comfortable with 2-circle diagrams is just to turn your paper so that the, see how this one is M first and then P? M on this side, P on this side, and then just ignore the S circle. Just ignore it, pretend it's not there. How would you do this if it was just a 2-circle diagram? You would put the X in the part of M that is not P, right? You'd put it out here. But you have this weird line right here. If you have a line, and this space is not shaded and this space is not shaded, you always put it on the line for a 3-circle diagram. If you have a line, put it on the line. Okay, so we've got one premise done. All right, the second premise, some M are not S. Just keep turning it. M, S. Okay, well you're gonna put an X in the M circle that is not in the S circle. Again, you've got the same situation. It would go in this one, right? But it would also go over here. It would go in both of these. You've got this line. Neither of these are shaded. Therefore, you put the X in the line. And then when you're looking at the argument upright, you can see what it looks like. So that is what the premises look like. Now again, you do not diagram the conclusion, but we've got this little one right here, so I'll show you what the conclusion looks like for this one. You've got your S and your P. Some S are not P. Right? It's just like that. Okay, so now look at this. Look at this, the conclusion up here. What you want is for this to appear in this argument. Do you see an X in the S circle that is not in the P circle? Ish, right? Ish. We've got this X sitting on the line into the S circle that is not in the P circle, but it's ish. It's not squarely in the S circle that's not in the P circle, so therefore it's invalid. Okay, so we've got 2 methods now that say that it's invalid. So now we're going to triple check by doing the third method, which is the rule method. 1, 2, 3, 4, 5. Now, my textbook actually originally taught it as 6, but rule number 4 and 5 are so similar. They're practically the same rules, so I just combine them because it's easier to just have 5 rather than dealing with 6. Rule number 1, the middle term must be distributed in at least one premise. Okay, great, distribution. What the hell is distribution? Look at this argument. Well, each kind of proposition, A, E, I, O, has a different form of distribution. Okay, so in my textbook, I've got the modern square of opposition, right? You guys have seen this before. This is not new. We've covered the modern square of opposition before, and in the modern square of opposition, you have the distribution, right? Predicate term, distributed, etc. So just look at your modern square of opposition to tell what is distributed and what is not distributed. These are all O's, and in O, only the predicate is distributed. In an O argument, only the predicate is distributed. Okay, does that mean that only P is distributed? P stands for predicate, but whenever the modern square of opposition says predicate, it is not saying only the term P is distributed and never S or M. That's not how it works. What it's saying is only the things in this column are distributed. So for all of these, because they're all O's, this is what's distributed. So now look at the argument. The first rule, right, is that the middle term must be distributed in at least one premise. Is M ever distributed? No, it's not. Therefore, invalid by rule number 1. Now, I want you to go through each rule and determine whether or not it's valid. But when you're done with this class, if you're ever doing this, you can stop once you hit an invalid, because all it takes is just one invalid rule and you're done. It's invalid according to the rules. So we already know that this is invalid based on the rules. We already know that, but we're going to go through each of these anyway. So rule number 2, if a term is distributed in the conclusion, then it must be distributed in the premise. What's distributed in the conclusion here? P. Is P also P, not just predicate, P. Is P distributed in the premises? Yes. We're good. A categorical syllogism cannot have 2 negative premises. Negative, negative. Invalid. Fails that test. And then 4, a negative premise must have a negative conclusion, and a negative conclusion must have a negative premise. We have negative premises and a negative conclusion. We have a negative conclusion and negative premises, so we're good. Final one, 2 universal premises cannot have a particular conclusion. Sums are all particular. This is a completely particular argument. So we don't have to worry about that. So, but it broke 2 rules, so it's invalid. First things first, we need to make sure this is a proper categorical syllogism. Therefore is unnecessary language. We don't need that. We need to have all nouns. Grapes, strawberries, those are all nouns. But tasty is an adjective. So we need to add tasty things. Morsels, whatever. I'm going to go with morsels. Bam, now we're dealing with all nouns. Alright, now, we need to make sure this is in proper order. We need to make sure that we have our major premise, then our minor premise, then our conclusion. So how do we know which one's which? Well, grapes is our S. It's always that way. Remember, your conclusion is always whatever S, R, or R not, P. Always, no matter what. That's always how it is. So some S, R, P. Alright. So we've got our minor premise here, and then we've got our major premise here. How do we know that? Because the P is the one that's the major premise, and we have P here. So we need to flip these. Bam, proper categorical syllogism. Major premise, minor premise, conclusion, ready to go. Okay, now we can transfer it down to proper categorical form. Now, what's the first thing that you do? Mood and figure. Next thing you do is mood and figure. So, Mood of the first premise. Some are, that is an I. All are, that is an A. Some are, that is an I. Figure, do our finger trick, right? We've got M on the far side, which means we're dealing with 2. So we have an IAI2 argument. Now we check our list to see if that is potentially valid. Here's the list. IAI3, but not IAI2. Therefore, this is invalid. Now notice that the first problem, I specified that we were doing the modern paradigm. But this one I have not specified whether or not we're doing the modern or the traditional paradigm, because I'd like to show you both with this one. So this list that I just showed you was the modern paradigm. Now let's look at the traditional paradigms list, right? We've got IAI2. We look at the 2 category. IAI is not an option there. So therefore, this is still invalid in both interpretations. So we've definitely got an invalid argument here. Now, next, Venn diagram. Remember what I said before? You always do the universal premise before you do the particular premise. Universal premises are the all and no. We have an all, so we're going to start with that one. That's the first one we're going to do because we want to shade before we do X's. So, all S are M. Let's just turn this a little bit. There we go. All S are M. Now, what is all S or M actually saying? There's no such thing as an S that's not an M. So all S's have to be M's. So there cannot exist an S that is not an M. So there cannot exist anything that is in the S circle that is not in the M circle. That's why we get rid of that. Shading eliminates it. It's as if it doesn't exist anymore. Next premise is some P are M. There we go. Okay, now we've got our P and M right here. Okay, some is an X, so we're putting an X. There exists something that is a P and an M, so there's something that is both of them. So it goes in the middle. Now, we've got 2 sections here, neither of which are shaded, and we've got a line between them. Remember what I said before? If there's a line, you always put it on the line. So, okay, now, that is our diagram for the premises. Remember, you never, ever, ever diagram the conclusion on the 3 circle diagrams, ever. They never go here. So if we want we want to compare it, we want to look at what the conclusion would look like, we'll do it on this little one over here. So, some S or P looks like that. Compare it to this one now, okay? SP, SP, there should be an X right here. Right here in the middle, there should be an X in here. There's an X halfway in there, but it's not actually solidly in there, so invalid. Okay? If I were to do this traditionally, the traditional diagram only affects all and no. We have it all. Okay? So it affects it. What my teachers used to tell me is to do it like a modern diagram first, and then to do the traditional, which is why I forgot about it, because it's the last thing you do. So what does it look like if you have an all situation? Well, in the traditional diagram, all looks just like this, right? It's these 2 that are affected, the S and M, because it's all S or M. It looks just the same, except it's got a circled X in the middle, right here. So we go right here on this line, because if there's a line, it goes in the line. And we put our circled X right there. It doesn't change anything, because our conclusion, you'll notice, still needs to have an X squarely between S and P, and that's still not the case. So it's still invalid. It's invalid in both traditions, in the modern and traditional interpretation, because there's still not an X squarely in the middle where it needs to be. Alright, so let's go through each of these rules. Rule number 1, middle term must be distributed in at least one premise. Well, here's our argument. What's distributed? We've got 2 I's and an A. So in I's, neither term is distributed. There's no distribution in an I. So the first premise and the conclusion, there's no distribution at all. In A propositions, the subject term, which is this column here, right, the first column, this one is what's distributed. So the S right here, that's the only distributed term in the entire argument. First rule, the middle term must be distributed in at least one premise. That is invalid because it's the S that's been distributed, not at either of the M's. So we already know it's invalid because it fails already. But we're still going to check all the others. So rule number 2, if a term is distributed in the conclusion, then it must be distributed in a premise. There's no distribution in the conclusion, so we're fine. 3, a categorical syllogism cannot have 2 negative premises. They're both positive, so we're fine. 4, negative premise equals negative conclusion equals negative premise. It's all positive, so we're fine. Then rule 5, 2 universal premises cannot have a particular conclusion. We only have one universal premises, the all. So that's fine as well. So it's just broke rule number 1, but it broke a rule and that's all that matters, so it's automatically invalid. So this argument is 3 out of 3 invalid. Now, we've already gone through 2 of these arguments. This won't take long. I'm going to show you how to do this basically in real time instead of stopping and starting through the whole thing this time. So you've got this argument. First thing we do is we check for whether or not it has nouns. So noun, 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 noun. We're good. Is it in major, minor premises order? We've got S, we've got P, reptiles is our P, reptiles is our P, and raccoons is our S, so it's in proper order. So we're ready to go. Next thing to do is to drop it into S&P format. The next thing that we're going to do is to do the mood of figure. So we have no, which is E, all, which is A, and some are not, which is O. So we have an E, A, O, and then for the figure, we've got M here and M here. If we do our little trick, we can see that lines up with the figure 1. We've got M something, M something. So we've got a figure 1. Now we just check our list. For the first, for modern, it's a no, it's invalid. But because this one has no and all in the argument, I do want to go ahead and check it in the traditional paradigm. So let's check if this works in the traditional paradigm. And good thing that I did, because, check this out, EAO1. It's there. So this is provisionally valid. That's what it means when it's valid in traditional, but not modern. It's provisionally valid. Okay? So it works in the traditional, it does not work in the modern. Next is to check the Venn diagram. So here is our diagram. Both of our premises this time are universal, so it doesn't matter which one we start with. I tend to start with A's, but that's just me. It really doesn't matter. You can start with the E if you want to. For A, the way that you diagram this, we've got S and M. So we're going to put it like that. All S or M means there's no such thing as an S that's not an M. So we're going to get rid of all of the S that's not an M. And then for no M or P, that means there's no such thing as something that's both an M and a P. So we're going to get rid of the middle section here. Now, do you remember what I said before about how whenever I was learning this, my teacher said to do the modern and then do the traditional? This is why. Because if we had done the full traditional for the A, we would have put a circled X right here on that line. But this section doesn't exist. That is why you do shading before X's And that is why you do the full modern before you go and do the traditional, so you can catch those kind of mistakes. So now that we've caught that, we can go ahead and do the traditional. We can do the little circled X's. Let's start with the A. With an A, you have a circled X in the middle, because you're saying that something does exist that is both of these things. So because this very center section doesn't exist, we would not put the X in the line. We would actually put it squarely in this section. And it's a circled X because it's traditional. And now for the no statement, we would have a circled X. We would absolutely have a circled X on this side. Always, always, always. You have a circled X on the subject side for a no. And because this section here does exist, we would have to put it on the line there. But you can also, and this is optional, not everyone likes to put a second circled X, but you can put a second circled X on the other side as well. So you can put it here. It really depends when you were learning logic. If you were learning logic earlier, like in the 40s through the 60s, through the 70s, I think in the 80s as well, you definitely put a second circled X. But more recently, logicians have realized this one isn't really necessary. You don't have to have it, so it's fine if you don't. You can just go with the one circled X, and that's fine. You can put both, whatever. Really, really doesn't matter, because it doesn't affect the validity either way. So we've got this argument. This is what it looks like. If you want to see what now we have to compare it to the conclusion. So if you want to see what the conclusion looks like, we'll do a little diagram. Remember, never diagram the conclusion on the triple, ever. This one never has the conclusion. So if you want to see what the conclusion looks like, you make a little one like this. So the conclusion would be there are S's that are not P's, so we'd have an X over here. So look at this diagram. Do you have any X's that are not P's? Well, we don't have any full X's, right? But we do have a circled X. We have a circled X squarely in the S circle that is not in the P circle. So this one, again, just like up here, this is provisionally valid. Second provisionally valid. All right, now rules. 1, 2, 3, 4, 5. All right, first one. You have to have the middle term distributed in at least one premise. So what is distributed? Well, for an E, you have subject distribution and predicate distribution. So both of these, subject column, predicate column, they're both distributed. For an A, it's only the subject that's distributed. Subject column, just this one, not this one. For O, you have the predicate only distributed. Predicate column, predicate, not subject. So those are all your distributed terms. So is there an M in that batch that is distributed? Why, yes, there is. In the first premise there, see? We have a distributed M, so we're good. That one does not violate the first rule. Second rule, if a term is distributed in a conclusion, then it must be distributed in the premises. Conclusion distribution, we have a P. Do we have a P distributed in the argument itself? Yes, we do. In the premises, we have P. So we're good there. Number 3, a categorical syllogism cannot have two negative premises. This one's negative, but this one is not. So we're good. 4, negative premise equals negative conclusion equals negative premise. We have a negative premise, and we have a negative conclusion. See the not? That's negative. And we have a negative conclusion, and therefore negative premise. So we're good. Not breaking any rules there. Final rule, 2 universal premises cannot have a particular conclusion. Both of these are universal. This one is particular. Okay, so here's the rub. In the modern paradigm, that is a broken rule. But in the traditional paradigm, that is not a broken rule. In traditional paradigms, you can have a particular conclusion and a modern premises. What determines if it's okay is not just that those are there, but that everything you're dealing with is real. So, mammals. Are mammals real things? Yes, they are. Reptiles. Are reptiles real things? Yes, they are. Raccoons. Are raccoons real things? Yes, they are. All of our terms are real things. Therefore, it is fine. It's perfectly okay. And so we have provisionally valid. Once again. So to reiterate with this argument, in the modern interpretation, this would be an invalid argument. But in the traditional interpretation, we have a provisionally valid argument. It's okay. Alright, so that is how you do the categorical propositions. I hope this was helpful, especially for preparing for the exam. I don't know if I said this in the beginning, so I'll say it now. I based these arguments, I just copied the forms, these parts, off of some of the problems from the exam. So these will be very familiar. You'll see these kind of things again. So this should help you prepare for the exam. If you have any other questions, please let me know, and I will do my best to answer them. And please let me know if you need any other videos like this. I really don't mind making them. I have a brand new camera for it and everything. So thank you, and good luck with the exam.